Hello, I'm Brian Farrell, and welcome to PACE IT's session on the Introduction to Network Devices, Part 1. Today we're going to be talking about the Open System Interconnection model, and then we're going to conclude with a brief discussion on some basic network devices. There's a fair amount of ground to cover, but not a whole lot of time, so let's go ahead and begin this session. Of course, I'm going to begin by talking about the Open Systems Interconnection model. The Open Systems Interconnection model, or the OSI model, was developed as a way to help disparate computing systems communicate with each other. It created a layered approach, a 7-layer approach to networking. This layered approach not only allows those disparate systems to communicate with each other, but it has the added benefit of helping to create a secure networking environment as well. Security can be placed at the various levels of the OSI model to create a layered security arrangement that will vastly improve the security of an overall network. Knowing networking devices and where they fit into the reference model will help the security engineer to create a more safe, secure, and efficient network. With that covered, let's move on to basic network devices. A switch utilizes an application-specific integrated circuit chip, or an ASIC chip, and it is considered a Layer 2 OSI device. The ASIC chip has specific programming that allows the switch to learn when a device is on the network and which port that device is connected to via that device's Layer 2 MAC address. Managed switches allow for security to be placed on the individual switch ports, creating a more secure networking environment. One caveat with switches, though: a switch will only communicate with local network devices. That means it cannot communicate with remote networks. Then there is the wireless access point, or the WAP. A WAP is a specific type of network bridge that connects or bridges a wireless network segment with a wired network segment. And it is also considered a Layer 2 OSI device. The most common type of WAP bridges an 802.11 wireless network with an 802.3 Ethernet network segment. All wireless access points are capable of utilizing encryption to help ensure a secure networking environment. And because they have that capability, you should ensure that all of your WAPs have encryption enabled. A WAP will also only communicate with local network devices, unless, of course, it's a wireless router. But that's a discussion for a different day. Then we have the Multilayer Switch, or the MLS. An MLS provides normal Layer 2 network switching services, but it will also provide Layer 3 or higher OSI model services. The most common MLS is called a Layer 3 switch. It not only utilizes an ASIC chip for switching, but that ASIC chip is also programmed to handle routing functions. This allows the device to communicate and pass data to non-local network devices. The MLS commonly implements security at Layer 2 and higher of the OSI model. MLSs are not very common in small networks due to their expense. Then we have the router. The router is the most common network device for connecting different networks together utilizing the OSI model's Layer 3 logical network information. Unlike the switch, which uses an ASIC chip, the router uses software programming for decision making. Firewalls and access control lists are commonly placed on routers to help secure networks. Speaking about firewalls, a firewall can be placed on routers or hosts. This would mean that it would be software-based, or a firewall can be its own device. Usually in that case, it's a network appliance. Firewalls function at multiple layers of the OSI model. Usually you will find them operating at layers 2, 3, 4, and 7. Firewalls block packets from entering or leaving the network, and it can do this through one of two methods. It can use stateless inspection. That's where the firewall will examine every packet against a set of rules. Once the packet matches a rule, the rule is enforced and the specified action is taken. The other method that a firewall can use is stateful inspection. The firewall will only examine the state of the connection between networks. Specifically, when a connection is made from an internal network to an external network, the firewall will not examine any packets that are returning from the external connection. As a general rule, external connections are not allowed to be initiated with the internal network. In other words, a firewall that uses stateful inspection will only allow connections to be made from inside to outside. It will not allow that outside entity to initiate a connection with an inside host. Firewalls are usually the first line of defense in protecting the internal network from outside threats. You can consider the firewall as the police force of the network. Then we have load balancers. A load balancer may also be called a content switch or content filter. Load balancers can be implemented to increase the security of a network by limiting or filtering the content that is allowed to be on the network. A load balancer can be a network appliance that is used to load balance between multiple hosts that contain the same data. That means that they will be spreading out the workload for greater efficiency. Load balancers are commonly used to distribute requests to a server farm among the various servers, helping to ensure that no single server gets overloaded. Last up, we have the proxy server. A proxy server is an appliance that requests resources on behalf of client machines. It's often used to retrieve resources from outside untrusted networks on behalf of the requesting client. A proxy server hides and protects the requesting client. That outside network never gets to see the internal client. Proxy servers can also be utilized to filter allowed content. And finally, a proxy server can also increase network performance by caching or saving commonly requested web pages. That concludes this session on the Introduction to Network Devices Part 1. I talked about the Open Systems Interconnection model, and then I had a brief discussion on some basic network devices. On behalf of PACE IT, thank you for watching this session, and I hope you watch another one soon.